Okay, let's look at question number 15. Now, this is a very unusual question coming in DSE. It's very difficult also, I would say. Now, if you look at this, what they have is x and y are jointly distributed, and they want you to find out that if you were to run a OLS regression on x and y, one's taking x as regressor, y as regressant, and then the other way around, what are the two slopes going to be? So what you need to understand here is that obviously there's this relationship which from higher level of algebra you can deduce that expected value of y given x is equals to mu y plus rho sigma y by sigma x, x minus mu x. But this is all too difficult, and obviously this is not the correct way to go about it, because DSE does not want you to do all this math, because you're not expected to know all this math. You're not doing an advanced degree in stats, you are doing a degree in economics. So what I feel is required here is to understand that since sigma x and sigma y are same, both these variables, they have the same variance. And now that they have a correlation factor of rho, what you can say is that expected value of y given any value of x, capital X equals to x, this must be equal to mu y plus rho times of x minus mu of x. Okay, so this comes from the fact that since sigma x is equals to sigma y. Alright, so since you know that these two sigmas are same, you should be able to derive this. The reason for this is very simple, that if x is equal to its mean, then you would expect y to be equal to its mean. For every unit change in value of x away from its mean, you would expect that y would go rho units away from its mean. Okay, so for every unit change in x from mu x, okay, y changes from mu y by rho units. So this particular formula satisfies that, and in order to build this, you do not need to do all the algebra which I've added in the subsequent part, and you can if you want access to this, you can just follow the link given in the description. You'll get access to the complete solutions. But the point is that you don't need to do this. This should not be required. This higher level algebra which I've added should not be required, but I've added it just as a proof that the solution is not correct. So if I proceed by this manner, if I were to run a regression of if I run a regression of y over x, basically taking x as the regressor, then I would see that the slope is going to be rho. Okay, so if I do a regression, if I regress y over x, I will get my beta 1 hat to be equal to rho. And by similar logic, what I have is expected value of x given y equals to small y should be equal to mu x plus rho times of y minus mu y, which implies that beta 1 hat for this case is also going to be equal to rho, which is again less than 1. So both the slopes are going to be less than unity. So that's less than unity and less than unity. So that's option number